Hello and welcome back to Doodles MD, where you get simplified medical information in relatable and applicable form. I remain your host, Folake Lawal, public health, internal medicine, and infectious diseases physician. We're talking this week about the musculoskeletal system on the Know Your Body series, and this will be the last part of that series where we wrap the normal discussion up. Stay tuned. So the musculoskeletal system is made up of muscle, skeleton, and then in between that, we have the tendons, we have ligaments, we have the joints, we have cartilage as connective tissues that either hold, them to the bone and the muscle together, or hold different parts of the bones together. Now, in talking about the skeleton is like the internal framework of the human body. And at birth, we actually are born with about 270 bones. As we grow older, some of these bones fuse together, and by the time we're adults, you have 206 bones left. So when they're doing like forensic pathology, if you watch all these fancy shows, that's how sometimes they're able to date how old someone was based on either the presence or absence of certain bones. The skeleton itself, the bone mass of the skeleton makes up about 14% of the total normal body weight. Of course, normal body weight, 14%. Now, in looking at the bones of the skeleton, there are 5 general types, and we have the long bones, which is one. And the long bones are the bones you find in the arms, the upper arm, the forearm, the thighs, and the legs. We have the short bones, which are usually found in the wrist and the ankles, and these bones are as wide as they are long, and they tend to stabilize joints in between joints. There isn't a lot of movements there, just like even though you're moving your wrist, you're not moving that part because it's in between and it's not the part that's moving. We have flat bones, and these flat bones, obviously they're flat, they serve predominantly for attachment to large muscle groups. So we're talking things about like the skull, the shoulder blade, right? In medicine, they call it the scapula. Also, the ribs are flat muscles, even though, they seem long, but their shape is not rounded like that of the arms or the legs. They're flat and they allow for attachment of a lot of muscles. Next, we have irregular bones. This is an example of this would be the pelvic bone, just because the shape is not quite anything. Some parts are flat, some parts are long, some parts are rounded, and everything is just ugh. Lastly, we have the sesamoid bones, and this word is derived from sesame seeds, and these are bones that are in between ligaments or tendons, and they're small. In some people, it's a normal variant. It's not present in everyone normally. In some people, it's a normal variant because in anatomy or in medicine, everything is not absolutely in a particular single way. There's always slight variations. Well, you find a little bit of this and a little bit of that. So in about 15% of people, you will find sesamoid bones normally. However, in other people, it is a sign. It can occur as a reaction to stress in that area. Now, when we're talking about the bones, I did mention joints, right? So some of these bones, we have them where they're fused, especially in the joints. We have fused joints or fused bones, and then individual bones. So for instance, if we look at the skull, parts of the skull is formed of actually multiple bones. We have parietal, the temporal bone, the occipital bone, and they're fused together. So they now form one structure that's called the skull. They're individual bones like those of the arms, the wrist, and different parts of the body. And these individual bones are joined to other bones by ligaments. Okay, so they have to be joined by fibrous tissue to other bones. As I was talking about joints, we talked about where the joints are, where the bones meet. And in between the joints, you have cartilage. Cartilage is a connective tissue. In other systems, they serve other functions where, you know, they are like appendages, like the ears, the nose. They serve as, you know, sort of tissue where you don't need hard bone, but you need something a bit stable and that's able to open. But in the musculoskeletal system, they are like cartilage that serve as a lubricant surface, a smooth lubricant surface for joints. For instance, your knees, your joints, as I'm moving them, people who have arthritis have lost their cartilage, so it becomes it's more friction when they're moving those joints, and it's painful. Tendons connect muscle to bone. Okay, so as the bone is attaching, it's not attaching directly, the tendon will connect the muscle to the bone. And we talked about ligaments connecting bone to bone. Before I move on from the bone, just to mention that the skeletal system has like two major divisions. We have what we call the axial skeleton, which is made up of, like, you know, it's kind of like the central part of the body, the skull, the vertebral column, the rib cage, and then you have the appendicular skeleton that's formed of the limbs and the girdles. We call them girdles, which is kind of like the joint system, the bone and joint system that holds the limbs to the center of the body, or to the axial skeleton. So the shoulder bones and also the legs and the hip bones form the appendicular system, as you see in the pictures. Moving on to muscles, in this particular system of the musculoskeletal system, we're talking about the skeletal muscles. In other systems, we've talked about different types of muscle. We have the smooth muscle, where we find predominantly in like the gastrointestinal system, the uterine system, and in some tubes in internal organs. We have the cardiac muscle, which structurally is kind of like a fuse between the smooth muscle and the skeletal muscle. In this system, we're talking about the skeletal muscle, and we have different groups of muscles in different, you know, shapes and sizes. And like we said, muscles are usually attached to bones through tendons. Okay, now a fun fact about the muscle is the largest muscle in the human body is a muscle we call the gluteus maximus. For those who are in the medical field, it's funny, we used to have a running joke in school, in my medical school, amongst my classmates, and this muscle is very powerful. It is located in the back of the hip, okay? And it has the job of actually holding the trunk, which is the middle part of the body, in an erect posture. So it moves from the middle of the hip in the back, the hip bone, down towards the hip, and it holds that. And that gluteus maximus is actually the buttocks bone, the buttocks muscle. So, you know, the running joke is about how, you know, large someone's derriere is and the size of their gluteus maximus, even though we know that the size and the shape is usually fat related. But exercising that muscle, people who are into fitness will know that it can enhance the derriere. Now, muscle is also, you know, important in that it's very useful and important in metabolism, and also in using nutrients, and also in weight loss. And that's why, you know, people are talking, when in exercise, muscle activity is very, very important, and that translates into either an active lifestyle or sedentary lifestyle, because you're not using a lot of muscles when you're sedentary, and then when you're walking or whatever it is, whatever muscular activity that you can do improves activity and burns nutrients. So what are the general functions of the skeletal musculoskeletal system? One is, you know, the obvious, supporting the body's framework, and it maintains the shape. You're talking about the head, you're talking about, you know, your posture and things like that. Movement, which also is another obvious function, where you want to move, you know, you need the muscle to keep the shape, you need the muscle to actually execute the movement of the joints and allowing you to move. Third is protection. protection of sensitive, important, vital organ structures in the body. So we think about the skull, protecting the brain. You think about the vertebral column, which is a spine that's protecting the spinal cord. You think about the rib cage protecting the lungs, the heart, and also parts of, the abdominal organs like the spleen and the liver. You have the pelvic bone protecting the pelvic organs and things like that. Then the bones are also responsible for production of blood cells in the bone marrow. So long bones and parts of the flat bone produce blood cells. Red blood cells, white blood cells, all of them have that. Fifth function is storage, and that is storage of minerals, calcium, phosphorus, okay, during metabolism. So when we're talking about calcium metabolism, the bone is very vital to that. The bone is made up of calcium, and you can move calcium, breaking it down and adding it. So when your body has too little, it can break down and supply from the bone. And if you have excess, it brings it to the bone for storage. The bone marrow also stores what we call ferritin, and ferritin is a storage form of iron. Iron's elemental name is ferrous. It's stored in large amounts as ferritin, and that can be stored in the bone marrow. The last function I'm going to talk about is endocrine system, which is related to the storage, and this is in terms of regulating fat deposition. Calcium metabolism is under endocrine system. And then also we talked about fat deposition and glucose metabolism. So those are functions that we have under the musculoskeletal system. In just wrapping it up, when we're talking about how the musculoskeletal system functions, some of it is obvious. The bones, in terms of protection, it's already formed, and the protection is, it's already there. When the bone breaks, things happen, things change. One that, is very obvious, and the function is obvious, but the process might not be obvious, that I'm going to talk about is movement. Okay. Now, when in other episodes that we talked about, I've mentioned that a lot of things start from the brain and the nerves, the nervous system. So your brain tells you want to move. I want to get up from this chair, for instance, or I want to talk. Then it goes to what you want to do and the parts of the brain that controls the area that is going to do that function. So if I want to move, it goes to, the parts of my cerebral cortex to say, hey, she needs to get up, activate certain muscles and move out of here, or she needs to open her jaw to be able to talk, and parts of her throat. So that information comes down through the brain to the spinal cord, and in the spinal cord, it goes out through the nerves of that level. Everything is always on levels mostly. And then it comes out through the peripheral nerves. Those are the last mile messengers, and it gets there. That nerve stimulates the joint, it connects with the muscles. It stimulates what we call, it's kind of like a mini electrical activity. Things change, sodium, potassium, they move back and forth, and they cause a change in the muscle, and the muscle is signaled either to contract or relax. So you have different groups of muscles. It's almost like they're opposing. So when I open my arms out like this, we have flexor muscles, which allows you to flex. And as I am contracting my flexors to flex, right, to reduce, they have to shrink in size for me to be able to move. I am also relaxing and extending the opposing group of muscles. So everything has to work in tandem. When one is stuck, the other is not able to do their job because they balance each other out. So your body does that. The muscle moves. The joints are innervated, but that usually is for sensation. Okay, that's for sensation. The muscles have the motor activity, which is what acts and does things. So that I just wanted to run through that. And we have, there's multiple abnormalities that can occur either with the muscle or the movement or even the innervation of that. And for muscles, most times, once the innervation is damaged, depending on what level, there's problems with movement. And if it's damaged at the level of the spinal cord, like we see in people who have spinal cord injury, due to a wide array of things, can be infection, can be trauma, accidents, and stuff like that, the damage is usually permanent, and because the nerve cannot regenerate from that point on. So I am going to put a pin on it and wrap it up here this week in talking about the musculoskeletal system. Thank you very much for staying with us through this series. We've been talking about this for a few months now. We're going to move on to the next phase where we start talking about diseases, common diseases, not so common diseases, really severe diseases relating to each of these organ systems. Thank you again for tuning in. Please like our videos, share with your family and friends, and continue to send us your comments and questions that we may answer. And also subscribe to our YouTube channel. Okay? Subscribe to our YouTube channel and stay tuned for more things. I am Folake Lawal, signing out on Doodles MD. Thank you. Bye.